Hey guys, this is one way of looking at how to keep track of stoichiometric molar conversions during a chemical reaction. In this problem, we have how many moles of oxygen gas are needed to completely react 8 moles of hydrogen sulfide. So you have hydrogen sulfide and oxygen gas react to form sulfur dioxide and water. I like to set it up like this, where I have the equation, the before, the change, and the after. And if I had graph paper, I would probably have this set out so that each of these things underneath each particular chemical had its own little segment, but hopefully you can probably still follow along. I usually put a little line between change and after, because oftentimes, how things end up is what you're going to be looking for. Plus, there comes a point where you need to build a wall. The very first thing is to balance the equation. If you need some practice balancing equations, aren't sure how to balance equations, or think you can give this one a shot on your own, it's H2S plus O2 reacts to form SO2 plus H2O. For time's sake, I went ahead and balanced it ahead of time, and I'm just going to write in the numbers. But if you'd like to pause it now and balance it on your own, great. What I got was 2 moles of hydrogen sulfide react with 3 moles of oxygen gas to form 2 moles of sulfur dioxide and 2 moles of water. 2, 3, 2, 2. It's reduced and everything. Okay, so the before section is where we just stop and think, what did we have at the very beginning? What we had was, and it's given in the problem usually, some of these things always are, 8 moles of hydrogen sulfide. So this part is 8 moles. And we have an unknown amount, I'm going to just use a question mark there, of oxygen. Some number of moles. Could be anything. And at the beginning, the before for these sides is really easy because we don't have any moles of the products yet. It hasn't happened. None of these have been produced, so I can put a 0 in both cases. This is also a good point to build your wall for keeping track in your reaction. Not in that part. Then, during the change, I like to just keep track of what changes when the reaction happens. So we know that all 8 moles of hydrogen sulfide are going to completely react, so we are going to lose minus 8 moles. And we're going to gain some number of moles here and some number of moles here. How to figure out what that is, I'll get to in a second. We're also going to lose some number, I don't know what it is, I'm not going to write it in just yet, of moles of oxygen, because this is all going to be reacted up as well. 8 moles minus 8 moles means we will end up with 0 moles of hydrogen sulfide. And in order to figure out what the other numbers should be on this, we look at our balanced equation. So for every 2 moles of hydrogen sulfide, we produce 2 moles of sulfur dioxide. Since 2 and 2 are the same number, this is a 1-to-1 ratio. That means 8 moles of hydrogen sulfide will react to form 8 moles, and I'll put a little plus there, of sulfur dioxide. And similarly, 2 to 2 means we get 8 moles here, and we'll have another 8 moles produced here. So in the end, we're going to have 8 moles of sulfur dioxide and 8 moles, harder to write, of water. And the last piece that we need to keep track of is what's going on here. How much did we start with? How much did we have to use? Well, for every 2 moles of hydrogen sulfide, we have to use 3 moles of oxygen. So this has a 2 to 3 ratio. You can take the oxygen, you can take the 3, you can divide by the 2, you can multiply by 3 halves. There's a lot of different ways to look at this, but ultimately, by looking at, I realize that I'm going to need to have 3 of these for every 2 of these. So if I have 1 of these, I have 1.5 of these. So 8 times 1.5 tells me that this number must have been, I must have started out with 12 moles, because 2 or 3 times 2, 3 halves times 8 is 12. During the reaction, I'm going to use up all 12 moles, and you're going to end up with 0 moles of oxygen remaining. There are other ways of thinking about this, but the reason why I like laying it out like this all first is because even if you don't read this question, or if the question turns out to have multiple parts to it, then when you come back, you know at each stage of the reaction how much of each chemical you have. And in my next video, I'll talk about how to use the same approach when you need to convert between moles and grams. You don't have to do this every time, but if it works for you to keep track of it like this, by all means, please use every tool at your disposal. And one of the biggest problems people can have in stoichiometry is that it's easy to get mixed up. So sometimes just laying it all out like this first can help make the rest of the problem easier to solve.